Okie dokie. So, moving on with 1.4, scientific notation. What is it? Why do we use it? It's used to express very large numbers. So used to express very large numbers or very small numbers. And the reason it was created, it's just more convenient. When you're having to work with large numbers or small numbers, it's just more convenient overall. Now, something else to think about is we need to be aware of significant numbers. What is the significant numbers? And when we're working with scientific notation. And we'll work through examples, but right now the definitions and the notes for your paper, significant numbers, they are those non-zero, so not zero, non-zero digits in a number. And we'll work through some examples here in a minute. The significant numbers, the non-zero digits in a number. Now let's take a minute and look at this table. Powers of 10. Positive numbers, negative, not necessarily positive numbers, positive exponents, negative exponents. Notice here, 10 to the first power. We talked about that rule towards the top of the page. Anything raised to the first power is itself. 10 squared, that's 10 times 10, 100, and so on. Notice these numbers get quite large. Then over here we have negative exponents. And notice how that negative, how it shifts the decimal sign to the left. 10 to the negative 2 shifts that decimal to the left, 2 points. So with that in mind, let's work through these two examples here real quick. Write, oh, that's a big number. Write 2,520,000 in scientific notation. Now, if I had to add and subtract and work with that all day long, I'd probably get kind of tired of it. So that's why scientific notation was created. And we need to focus on what's called the significant digits. Notice significant digits, anything that's not zero. So it looks like 252. And so rewriting that into scientific notation, 2.52 times 10 to what power? So thinking about it, here's my decimal spot. How far do I have to move it? 1, 2, 3, 4, 6. Putting that right here, 2.52 times 10 to the 6. And notice 2.52, those are called my significant digits. They are non-zeros. And of course the 6 comes from how far am I having to move that over? Now let's do B. Write 2.9 times 10 to the negative 3 in standard form. So there's 10 to the negative 3. And we have to take this significant digit here, 2.9. 2.9, so to the negative 3. It's going to look something like this. How far over am I having to move that decimal sign? How far over? 3 spaces. And so that's why, notice my significant digits, 2.9, are down here. Okay, we're going to work through some more examples in the next video.